Okay. Muy buenos días para todos. Tendremos como conferencista a Mine Çetinkaya Rundel, a senior lecturer, University of Edinburgh, data scientist and professional educator, and associated professor of the practice at Duke University. Su conferencia será R for All, Welcoming and Inclusive Practice for Teaching R. Okay, go ahead.
All right, wonderful. Well, thank you so much for having me and gathering at this early hour for you. It's a little bit later in the day for me. So as you perhaps know from the program, I have a variety of roles in my life, but they're all centered around education. And my kind of main interest is teaching R to people who have no programming background at all. I mostly teach statistics and data science, and R becomes a huge part of it. So this talk is about some of the welcoming and inclusive practices that one might choose to adopt in their teaching as they're teaching R at any level, really. Some of it will be geared particularly towards people who are just beginners, but not necessarily all of it. So to start with, let's talk about, let's say that you want to teach R. What are some of the things that should be on your radar? First of all, I don't know if you're familiar with this idea of learner personas at all or not, but that is, as you're designing a new course, whether that's a semester-long course at a university or a short workshop, you want to be thinking about who your audience is. And the best way for doing that is to think about this idea of learner personas. Who do you want to... I apologize for the cat. This might happen a few times. Who is your audience who is learning from you, and why are they learning from you? Next, you want to think about what are the learning goals for your course, and you want to really outline those goals. Whether your learners will achieve them or not, you really have very little control over that, but you're going to try your best. But that's something that needs to be on your radar. Then you turn that into a list of topics. Then you turn that into a syllabus. You think about what resources are going to accompany it. And if you're teaching R or any sort of computing, you really want to be thinking about what is your computing infrastructure going to look like. Are people bringing their own laptops and installing software? Are you teaching on something like RStudio Cloud or somewhere in between? But is that it? This is the standard for at least designing a university course that I can think of, or most of the workshops that I've pitched to give at places. But there's really one other thing as well. So what I'd like to do is to get a little bit of audience participation at this point. So if you go to slido.com and join by typing the code R432, it should pop up this question. And I'm going to give a little bit of time for people to answer. You can just give free text answers. And the question I want you to think about is, think back to when you were first learning R, or the first programming language that you learned. What about the instruction made it more challenging for you to learn this content?
La idea es que visitemos esa página web, introduzcamos el código que aparece ahí y respondamos que en el momento en el que estábamos aprendiendo R o comenzamos a aprender R, ¿cuál fue el tópico o la parte más difícil de todas? Ella nos sugiere que coloquemos texto libre, o sea, no hay, digamos, restricciones al respecto.
And feel free to answer in English or Spanish. Or, I'm happy to collect answers. This is more for each other to see than for me. I actually am going to be post-processing this data to see what comes out. But if you have anything that you can remember, thinking back to when you were first learning R, what about the instruction made it more challenging for you? What I'm going to do is I'm going to leave this poll open throughout the duration of my talk. So if you think of anything, go ahead and put it in there, and then we might come back to it at the end.
Don't worry that we will work out the translation from Spanish to English.
Okay. All right. So now let's start thinking about what are the things that you might want to do in your teaching. The first thing is get to know your students. What do I mean by that? This is a tweet that I came across about maybe about 2 months ago now, over the summer, as I was preparing for teaching for the new semester. And it was about an beginning of the semester survey, which is something I've been doing for as many years as I can remember of myself teaching, and getting to know you survey that you can conduct for your students such that they can tell you at the beginning of the semester some of the things you might want to find out about them. One of the things I didn't have initially in my survey was something about pronunciation of people's names. I have a name that's hard to pronounce for many of the people who I teach, and equally, I find it sometimes difficult to pronounce my students' names, and what I actually end up doing is try to avoid pronouncing them if I don't feel comfortable with it myself. So this is an option that you might have to do, is actually ask them ahead of time, so you don't necessarily feel like I don't know how to say this when it comes to speaking with your student. This is just one of the features of the survey. There's a whole other set of questions. What I've done actually is, along with these slides, I've made available a version of the survey that I have used in my class. So if you are teaching and you would like to borrow a version of it, you're welcome to do that. But I'd like to show you something from this survey. So this is a survey that I've done after the first day of class. And the thing I'd like to show here is these answers to these two questions. The first question is, were you able to hear me well during the first lecture? And many people said yes, but some people indicated they were able to hear me, but not the students who asked questions. And other people said something else. No, they couldn't hear me. And similarly, were you able to read the slides easily during the first lecture? And I can see that for some people, clearly the size of the text was not viewable. The other was a question answer where they could actually kind of freeform answer some things, and they said some of the colors were hard to see and stuff like that. And this is the sort of thing, if you don't ask your students on the first day of class, you're probably going to find out at the very end of your class when it's too late to make any sort of changes. Number two is help them get help. We always talk about students should be always asking questions. We want to try to encourage them to ask questions. We want to provide a welcoming environment where they will feel good about asking questions. But how do we help them get help? So obviously, if you're using R, you can use this question mark syntax, right? So you can, for any function, you can do question mark and then the function name, and the help window will pop up. Well, that help window is actually quite cryptic. Here's a very, very simple function, the mean function. We probably all know what it does. And maybe the students do as well, but sometimes they need to look into it to see if we were going to take a trim mean, or if you had NAs in your data, you might find yourself ending up in here. And you can see there's a lot of what might seem like extraneous information to a beginner. It's not extraneous to somebody who is familiar with R or any sort of programming language, to see what are the real reasons why you might want all of this detail in documentation of your functions. But to a beginner, this is a lot of information. So one of the things I like is showing them this annotated version of a help file. And this is actually, I've taken this from here. Please, data visualization book. It's a wonderful data visualization book and has a bit about kind of introducing people to R. And I think that's such a smart idea to annotate this sort of thing for the students. So not just tell them, go read the help, but also help them with how to read the help. Another thing is helping them with Googling things. We always talk about, well, people should be open to actually finding answers for themselves, but there are a variety of ways you could be Googling things. So let's take a look here. Say that I want to get some help on joining data frames. This is how I would probably go about doing the search myself, probably pretty quickly scrolling around, and finally realizing, okay, maybe that's not the answer I want. Oh, here's a dplyr answer. This is probably what I want to do. And then I would copy and paste it. This is something I could do in front of the classroom, but I haven't really talked the students through what I'm doing. So why did I skip over the first few answers and actually scroll down here? Really, if you're going to be helping students with their search, what you want to do is actually talk them through what's happening. So here, I want to join data frames, and I'm using tidyverse code, so I'm going to add that. Here is one option. It is actually the help page for dplyr. And the nice thing about this help page is to be able to scroll all the way down where you can see the examples, and not only the examples that you would get in the help window for your, if you were doing the search in the RStudio, but actually the results as well, so that you don't even have to run the code. So this sort of talking your students through how to look for help is going to be a lot better time spent in the classroom than them watching you quickly Google through things, where you're able to do that quickly because you know what you're looking for, but they have no idea. Another option here is to use some packages that are designed for that. So there's this wonderful little package called Searcher, and it basically offers some preliminary support for automatically or manually searching errors that are generated in R. So what do I mean by that? Say I have this R script, and I start load the package Searcher, and if I say I want to search something on Stack Overflow, it will actually pop open the window for me. This to me is like a little bit, well, people probably would just go to Google to do this, but let's take a look at this. Let's take a look at another thing. How do I actually search for an error? Let's try that. So here I have a, I get an error, and then I say search Google, and basically what it searches is that error on Google. So for a lot of beginners, when you start doing this, when you get an error, you should just Google it. It doesn't come easily to them. At that point, sometimes they feel stuck about what happened, or maybe they don't necessarily copy and paste the right bits of that error in order to be Googling it, but the Searcher package basically helps with that. You can actually add it into your R profile in a way where every time you get an error, it would actually pop open a search window for you. I find that to be a little bit obtrusive. Sometimes I just want to work through my errors myself, but this is a really handy tool for searching things, and you can search it on Google or Stack Overflow or RStudio Community. It has functionality built in for that. And finally, another wonderful package called Refractions, which basically forces students to fulfill the technical criteria so the instructor can focus on the help that only a human can provide. So let's take a look. This is a screenshot from Piazza, actually, which is the kind of question and answer platform that I use in my teaching, and I know a lot of people do who teach computing as well. So this is closed to the classroom, so not as open as Stack Overflow, but still, even though I kind of know what the students might be asking about, because it's probably based on a homework assignment that I gave, this is still not a very good question. I'm trying to calculate summary statistics for the data set called MPG for cars with different numbers of cylinders, but I'm getting an error saying summary must be length 1, not 6. Can anyone help? So here the student came across an error. I can kind of tell what they're saying, but only because I've come across that error before. It is probably very difficult for someone who is new to R to figure out what they may have done. What we want to always encourage the students to do is share their code and also their error verbatim. So here is something they can do. Using the Refractions package, you can actually try out your code, the code that gave you an error, and then you can, what you can do is it will copy the code that you ran and place it into your clipboard so that you can actually paste it onto somewhere like Piazza. And now the student's question is going to look a lot better. They're basically saying, this is the code I ran, and this is what the error that I got. So if they now add a little bit of narrative around it, this is a lot better question, and one not only I can answer for them, but probably one of their classmates as well. Number 3 is live coding. There's a lot of research on the benefits of live coding, so doing this in front of your students. If you've taken any sort of math class, like maybe a proofs-based math class or one where you had a lot of derivations, we like it when professors slow down and actually show their steps on the board, as opposed to just give you a slide full of everything and you're just supposed to say, okay, this is how I would go through it. Similarly, live coding is the same idea. Instead of putting a block of code on your slides for students to see, even if you were going to meticulously go through it, it's still a better experience for them to see you doing it live. And truthfully, you're probably going to make some errors. You don't want to be completely unprepared. You don't want to be just like figuring things out as you go, probably. But even with a little bit of preparation, you're probably going to make some errors, and you might actually narrate how you resolve them. And I think that's a really, really important learning opportunity for students. But there are ways of live coding that are good and ways that are not so bad. This is how I tend to keep my RStudio IDE. In the morning when I wake up, this is probably what it looks like, because maybe I was working late in the evening, and I tend to use the dark mode so it doesn't hurt my eyes. This is great. But not only am I using the dark mode here, if you're familiar with the RStudio IDE, it'll look a little bit unfamiliar to you here because the panes are moved around. My console is where usually my plots would be, for example. And the reason why that is, personally, I like this layout a lot better when I'm developing teaching materials. That being said, showing students something so unfamiliar and hard to read is not going to be great. So instead, when I'm doing actual live coding in front of the classroom, I reset everything to factory defaults, basically. So turn RStudio back to its kind of neutral color plate, zoom in so the code is actually readable. Now, if the learning goal for this was to show students how to change themes and stuff like that, you should be doing that live in front of them. Other live coding tips. So we talked about using default appearance and font styles, zooming in and using larger fonts. I would also recommend avoiding keyboard shortcuts unless you're really, really carefully narrating. The thing is, when you're live coding, your students only see what you type, not your hands. I have this dream of one day I'll be doing live coding in a classroom where the students not only see what's on the screen, but maybe there's also a camera that shows my fingers so they can see the shortcuts. The thing is, even if they could, I think that's like a hard thing for them to know. So unless you're carefully narrating this stuff, I would recommend avoiding any sort of shortcuts. The other thing is test your physical space. So before you teach in a classroom or any setting that you're going to teach, put your slides or any sort of code you're going to show on the screen, and then move all the way to the back of the screen. And do this with the lights, however you're going to be adjusting them, and see if you can actually see it. Recording is a really easy thing to do while you're doing live coding. Most computers right now have a built-in screen capture. So I'm not talking about recording your face as well and then post-editing things. That's something you could do, but you don't really have to. That's a commitment. But simply hitting record as you're doing something on your screen is pretty easy. And then you can upload that to someplace like YouTube or Vimeo. And if you don't want to share it with the whole world, but only with the students you're teaching it, you can make it a private video and only share the link with them. What that does is it allows them, it gives them that nice record. So if there's one drawback of live coding, it is that there isn't as nice a record of what happened as if you had a meticulously put together slide deck. So the screen recording will serve as that backup option. Additionally, if your audience's first language is not the language that you're teaching in, they very well might want to go back and listen to things. Maybe one other time, maybe slowing things down, maybe jumping around a little bit. And I think that given it, in this day and age with the technology, how little effort it takes, I think it's a wonderful thing to just go ahead and do that. Another thing is broadcasting. So this is something we've been playing around with. When we're doing live coding, oftentimes what we expect is students to be looking at the screen, so the big projector in front of the classroom. Let's say that you followed all these tips, your fonts are large, they can see it, but ultimately they're just watching you. And if they're going to be going along with you, they simply need to type as fast as you do and kind of do the same thing on their computers. Sometimes this works out well, sometimes not so much. So what if we had an easy way of broadcasting what you're doing to the students' computers in the classroom? If you've ever taught in one of these like highly technological learning spaces, they have things like this built in sometimes. The instructor computer can kind of be beamed to all the other computers in a lab. But how do we actually do this in another setting where we don't necessarily have that option, but what we would like to do is for students to be able to see this on their computer. So Colin Rundel has been working on this package called Live Code, and I haven't been developing this, but I have been testing it out, and I've tested it out a few times in the classroom. And the idea is that it actually serves the file you're working in. So whether that is your an R Markdown file or an R file. So imagine this is a script that I'm actually working on, and the function I run is serve file. And what that does is it actually generates a short link, a bit.ly link for what I'm doing. And this is what students are able to view either in their RStudio viewer or on a browser. So the idea is that this is not a video that they're watching. They're actually viewing this code so they can copy and paste from that easily. And all of this is happening either within the IDE or at least in a format that's easy to copy paste from the browser to the IDE. So the package is under development, and I think it'll grow a little bit over the year, but I have, as I said, tested it out, and I can say that this idea of trying to get what you're doing closer and closer to the students is, I think, really important. Number 4 is leveraging visuals. Some of us learn well with visuals, and coding is one of these things that's sometimes harder to visualize. So how can we do that? This is a tweet from Hadley Wickham, which I can't believe it's like almost, 4 years ago, about indexing lists. The reason why I say I can't believe is I remember seeing this picture, and when I was putting together this talk, I was like, I know exactly which picture I want to show here on this slide. So this is about indexing lists and how he was thinking about, well, it's a bizarre thing to put, I think, pepper packets into a pepper shaker, but you can think about it as the first picture is an object in R, and then you can go in with square brackets once, and then with double square brackets another time, and then even further in and get to the pepper by doing the double square brackets twice. So this is about list indexing. And it's one of those things where you can show it to students in R, obviously, by indexing a list, but you really don't have another way of doing it. So if a student doesn't understand what you said, you simply have to do it again and again and again until maybe you stumble across the right set of words. So here's a visual that explains that. Another one is Jenny Bryan's tutorials about doing iteration in R with the per package. So this is an idea of kind of doing things over and over again. And she has at this link that you can see on the slides, a series of photos that she took of, I think, her kids' Legos that basically exemplify what each of the per functions are doing. So it's a nice way of explaining these functions for the first time along with the visuals that go along with them. Allison Horst is not only a data science educator, but also an illustrator. And what she does is she actually makes these illustrations of various R packages or concepts. And they're kind of cutesy. I think people like them a lot. I find them cute. And they're just another way that you might be able to get your point across. This is not to say that this is the only way you should be teaching, but I think it's a nice supplement. And the thing is, you may not necessarily have the artistic chops. I don't think I do, but there are these resources online, and you really can kind of leverage what's already out there. All of her illustrations are openly licensed, and actually there's a set of Spanish versions of the illustrations as well. But also leverage non-visuals as well. So last year, I gave this talk, Coral let them people were tweeting about it, and one of the things I said at that talk, and something I fully believe in, and it kind of forms my teaching ideology, is you should teach data visualization first, because it's a good way of teaching stuff, and it's a good way of wrapping your head around stuff. I got one critical comment on Twitter that has stuck with me because I haven't been able to find a real answer for it, is what about some non-visual ways of representing data based on other senses? Because what if you have a student in your classroom who is visually impaired? And I think that's a really, really good point. I don't necessarily have an answer for that. There are people who are doing interesting things about representing data through sound or through other senses. I find these to be incredibly interesting. I have not yet seen how we can really incorporate that in our teaching. So if anyone has ideas, I'd love to hear about them. But I think the important thing is visuals are nice, but we probably shouldn't be just telling ourselves as long as we got the visuals, we got everyone in the room. There are people for whom we need to reach in other ways as well. Number 5 is define and pronounce the terms. So here's a term that if you've taken a computer science class before you're learning R, you probably are familiar with. What is a double? It's a type of data, data in R. So we could introduce that to the students that way. And chances are there will be some students in your classroom who has taken some computer science and has been introduced to this, and some not. So the tip here is to never assume that your audience knows particular terms, even if they might seem quite elementary. Always introduce them and define them before you start using them. Another one is pronunciation. There are a lot of R functions that I actually will avoid pronouncing in public because I'm not really sure that I'm pronouncing them right. One of the reasons why I like the tidyverse functions, like the dplyr functions, is there are verbs that I know how to pronounce. If you're interested in kind of work around how pronunciation may or may not get in the way of learning, Feline, who gave a talk last year at our StudioConf, said a bit about her research regarding this. So they actually did some experiments about how code sounds to people. So if I say X and then the equal sign and then 5, how do I read it? Is it X is 5, X equals 5, assign 5 to X? None of these are wrong, but which of them should you be saying? So I think it's really important if there are some norms for the language that you're teaching, that you explicitly explain these to your students. Number 6 is highlighting diversity. So what do I mean by that? As people who are data science educators, I think we have an opportunity to highlight certain sorts of data sets and not others. There is this wonderful resource from the Significance magazine. Hey, I'm sorry. From the Significance magazine, about LGBT plus resources for statisticians and data scientists. And so this is a group of statisticians who wrote this article about what are some data sets that you can use that don't just characterize gender as a binary variable, simply because that's how it's been done before. There are many reasons why certain surveys and things like census continue to do that. Maybe things will change, maybe things won't change right away. Things changing will take time for sure for a survey that's been going on for years and years, but there are many, many other surveys that are not limited to that and other data sets. So while Significance magazine does require subscription, this particular article is openly available to everyone. And if you are an educator who uses data sets in their teaching, I highly recommend that you browse through it. So here are some of the examples from that article that they have said are openly available data sets. And you could either be choosing to actually be studying data about LGBT concerns, or you could simply be studying something entirely different. So the US Center for Disease Control, CDC data, you could be simply doing an analysis of something about flu, for example. It just so happens that the gender variable is not binary coded in that data set. There's also language diversity that I think we should highlight to our students. So I'm not sure if you're familiar with these two projects. The R for Data Science book by Hadley Wickham and Garrett Grolman has been translated to Spanish, so it's R for DS en Español. And also there is a package called Datos that has the data sets that are commonly used in our examples, so your iris, your MT cars, so on and so forth, where the documentation and the variables have been translated to Spanish. And there's also on the RStudio website, you've probably come across the RStudio cheat sheets in your perusing. There's also translated versions of these on the website, and these are completely user contributed. I highlighted the Turkish ones here because my first language is Turkish, and so it's really nice for me to see these cheat sheets that have been translated by users. And if you have done any translation, submit it to us and we'll certainly highlight them there. But the thing is, these things exist and you may or may not know them, but even if you do, your students don't necessarily know them. So I think even if for you language is not a concern, it's important to highlight these different resources to your students, especially if you're teaching a large class, not making assumptions about people's languages, but just saying, hey, if this is useful for you, this exists. Number 7 is providing instant feedback. So what do I mean by that? So I'm going to walk you through how I do this in my class. So in the data science course that I teach currently at University of Edinburgh, students submit their work using GitHub. So every single assignment is submitted as a GitHub repository. So I assign a homework, and a week later, the homework is due. A week later, they get feedback. That's a pretty long turnaround, and I think there are some things that we can actually give them automated feedback on. And the idea is to leverage some software engineering tools for doing that. So say a student is working on an R Markdown file or an R script, and then at some point, they push their work to GitHub. And what that does is it actually triggers 2 GitHub actions. One of them is, does this R Markdown file actually knit, or is there an error in it? You would think people wouldn't push without knitting their work, but that is not true. And also, am I pushing some extraneous files to my repository? So you might have some additional files in there that ultimately don't need to be in your repository. And kind of project organization is something I teach and emphasize in the class. So these are the 2 things that a human does not need to check these. A machine can be programmed to check them, and we can actually give students instant feedback on it. And then if the answer is yes to these, they get these little badges on their repository. So this was just from a recent lab that the students worked on. And if it fails, then it would say something like net failing. So how does this work? I actually, GitHub Actions is a new service, a continuous integration service that GitHub is providing. And if you're using it for nonprofit work or education work, you can make use of those for free in private repositories. So the idea is you write this YAML file, and even if you're not familiar with YAML files, you can see that all I'm saying is in this repository, look at this lab 07 R Markdown file and simply try to knit it. And so that knit button in the RStudio IDE is basically equivalent to the render function in R Markdown. So the idea is simply try to knit it. And if it passes, it passes. If it doesn't, then the student would be getting a notice about that. And similarly, I have another YAML file that checks for allowed files. So I list what are the files they're allowed to have on their repository for a particular assignment, and it gives them this. Now, one other thing is that certainly does not need a human, and in fact can be super tedious for a human to check is the code following styling guidelines? There's this package called Styler that you can actually use to give you feedback on whether you have styled your code properly. So we can actually tie this into a GitHub action as well. And here is how it looks. Basically, every time, or actually I don't do this every time, but I give them once a day during the time that they're working on their assignment, around 7 a.m. every morning, this action runs, and it basically creates a draft pull request for them that says, this pull request contains the results of running the automated R code formatting tool Styler on your repo, and it's based on the Tidyverse style guide. It tags the student here. I didn't want to present my student's name, so this is a random student that I'm showing you, and they can actually click on this diff here and see on one side their submission, and on the other side what the style look like. So you see, this is really nitty-gritty stuff, like you're missing spaces, your assignment operator is wrong. Again, not things a human is needed for, and honestly, not even things a student needs to see in writing, but it's very useful for them to see this diff visually. And the goal is hopefully before they turn in their homework, they actually make all these changes themselves. The thing about doing this sort of automated feedback is a lot of it is actually geared towards pointing out negatives, things that didn't work out. So there is this package called Praise, which if you do something good, as in your code runs, you can actually tie it up to give you something like, hey, high five, you did a good job, or something like that. So I think it's good to take a note from that and also try to comment on positives as well. This is not something I've been able to implement yet, but I've been thinking about what are things that's not going to look gimmicky, because that's not necessary, but something that might be confidence boosting for students that we can tie into something like GitHub Actions, where they don't just get notifications when things go wrong, but actually maybe get a notification in their inbox saying, hey, we ran this and everything was good. Good job. Number 8 is inviting peer feedback. So the reason for doing something like peer review, well, there are a variety of reasons for that. And one of them is you might reduce grading on yourself. But more importantly, what it does is it basically makes expertise contagious within your class. It helps them see their work through another's eyes without the instructor having to point out flaws. Sometimes what this helps with is when a student tries to reproduce another student's work and realizes how difficult it might be if things weren't set up the right way, they realize, oh, all these comments I've been getting weren't just trying to be nitpicky. This truly is a difficult thing to do. Or they might see, hey, this person did something really cool. I wonder if I can do something like this myself in my next assignment. So as part of the GH class package that I use to run this course on GitHub, over the summer with my intern, Therese Anders, we developed these set of functions that basically allow for peer review. So students do their work on a repository, and once that's done, using a set of functions, we can randomly assign it to other students to do peer review. So they review them anonymously, they give them feedback, they edit their document directly, and then we run another function that creates pull requests that show the students what are the pieces of feedback that the students gave. I actually recently, we built these functionality over the summer, and just recently did a pass through of this in my teaching this year with 100 students in my class. And things went okay in the sense that there's some stuff we need to do in terms of the functionality to be a bit smoother. But from the students' perspective, what I've been seeing is that their feedback has been incredibly constructive to each other. And what we've allowed them to do is to resubmit their project proposals after they saw peer feedback, and I can see a clear improvement in their work. So they realize that this is not just for make work, they actually can learn from their peers and in fact increase their scores. And number 9 is amplify diverse voices. So I like doing things like showing some students data analysis in the wild, maybe some blog posts that might be inspirational for them or relevant to what we are doing in class. And then I get to choose whose blog posts I actually want to show the students. And there are a variety of people who are active, kind of writers, bloggers who do cool art stuff, but I try to make a point to amplify diverse voices. So Bruna is a PhD student in Ireland, I think, right now, and she does machine learning stuff, but she also has a personal interest in working with music data. Our music tastes kind of align, so I like showing this one example from her blog, a blog post that she had done, looking at kind of songs and lyrics and their translations. She's a Portuguese speaker. And so this is something that I highlight before teaching text analysis. Another one is this article by Brooke Watson. She is a data scientist in New York, and she did this like nice interactive graphic about how the name Beyonce has been increasing over the years in the US. This is a lot of text analysis stuff as well. And this is Omaima Saeed. She's from Egypt, and she has this wonderful post that's actually highlights the strengths of some of the dplyr functions and has built them into a Shiny app as well. Basically, it looks at question tag pairs on Stack Overflow. So the dplyr functions is something I teach in class. So these are just links that I throw in the middle of my lecture sometimes saying, hey, here's a nice write-up that you can read about them as well. If you are interested in amplifying other voices, Our Ladies has a directory online, and you can actually search by country people. So you might look for people who are from your country, and see what their work is like. A lot of these people are willing to be speakers at things. And that doesn't always mean travel, just like today. I didn't need to be there, but I'm talking to you. I've actually called on Our Ladies friends from there to join my class for 10 or 15 minutes at a time to tell me something about how they do their work. And I think it's been a really good experience to expose students to these voices. And finally, make room for creativity. What do I mean by that? This is how my class ends at the end. The end project is pick a data set, any data set, and do something with it. This is the project in a nutshell. I then go on to explaining exactly how students will be assessed, because that would be kind of uncomfortable for students who get graded on work. But the idea is that get them to a point where you can let them be creative, as opposed to simply giving them didactic homework from week in and week out, and let them actually explore what they want to do with things. I think this is a nice way to end things. Pedagogically, there's a lot of support for this in kind of education literature, but I have to admit, it's also grading these is no small feat. So having a project component like this in your teaching may be difficult, and also you may not be teaching something like a semester-long course, but just a workshop. So how do you then incorporate this? So here are a few other examples of things that actually bring up people's creativity that you could do even in a 2-hour workshop. So this is an assignment on creating the ugliest ggplot2 theme ever. This is the winner of them. And if you look in that link, there's a whole Twitter thread about all the really, really ugly ggplot themes people have developed. The thing is, they learned a lot about ggplot doing this, right? You can't just stumble upon this. You really need to understand how ggplot works to be able to make one of these. Another really fun assignment is draw a Christmas tree. So this is just saying to students, after you've taught them some plotting, do it. No instructions whatsoever. How would you go about it? And you can see people have taken very different ways for doing this stuff. So those were my 10 tips. And I hope that they've been inspirational. One thing I wanted to mention before we wrap things up is that there were these wonderful illustrations throughout the talk, and those are by Desiree de Leon, who was an intern at our studio over the summer, and she does these really nice illustrations that I've borrowed from, and she open sources them as well. So if you are looking for visuals like that, you may want to check out her work. And all of the slides are available at that link on the screen. So you can get to a PDF version of the slides there, which then will take you to all the other links of resources that I mentioned throughout the talk. And I'd be happy to take any questions.
No, thank you very much for your wonderful talk. I will open the microphones to the audience, so if they have any questions, they will be able to talk to you, okay?
Okay, wonderful.
Bueno, le estaba diciendo que muchas gracias por su maravillosa conferencia sobre los tips de cómo enseñar y que desde este momento pues los micrófonos están abiertos por si ustedes tienen alguna pregunta al respecto o quieren hacer alguna intervención o necesitan una aclaración adicional acerca de lo que ella dijo sobre cómo enseñar R. So, Mina, we have a question from one instructor. If an instructor is teaching data visualization for new R users, what do you recommend? Graphs made with basic R or graphs with specialized packages like ggplot2 or lattice?
My choice would be ggplot2, and here's the reason for that. I think one of the things that is appealing about ggplot2 is it is a lot easier to move on to do multivariate visualizations with ggplot2 than with base R. You need to have some comfort level with base R before you can make visualizations where you maybe facet by variables. Lattice is a little bit easier in that regard as well. So Lattice is a little closer to ggplot2 in the sense of it's a bit easier to do things like facets and coloring points and stuff like that. In terms of the choice between Lattice and ggplot2, I think the syntax of ggplot2 is easier to read. If you are then planning on teaching something, other packages from the tidyverse, this idea of the data frame being the first argument carries through all the tidyverse packages. So I think that's another good argument for it. And finally, another thing I will say is that the visualizations look a lot more modern with ggplot2. And this might sound like a cosmetic concern, but I don't think it's limited to that. In this day and age, people are exposed to pretty cool data visualizations on the web. So when the visualization that they make looks nothing like that, that can be a little bit discouraging for students. Can you make awesomely, fantastically modern looking graphics with BaseR? You absolutely can, but you need to know exactly what you're doing versus the out-of-the-box visualization that you're going to get with ggplot2. I think looks a lot closer to something that was developed in this decade.
Thank you very much. Otra pregunta. No puedo ir hasta allá, pero entonces le puedes preguntar en español o en inglés, cualquiera de las dos. Si es en español, pues yo ayudo ahí un poquito.
Hi, my name is Daniel. I'm a student. Precisely because you were speaking about all the tidyverse universe, ggplot2. I have that when you're learning R, you have like a whole way of managing data with the basic like programming logic, and then you have the option of using the tidyverse universe. Now, the thing is that if you learn directly in R, it's not the same logic that when you're going to use tidyverse. So it is recommendable to start directly learning or teaching people in the tidyverse universe, or first you should like understand one logic. What do you recommend?
Te tengo una mala noticia, ella no te puede escuchar porque el micrófono de ella es este. Pero le voy a resumir la pregunta. Básicamente es que si obtienes un error en R normal, entre comillas, y un error en tidyverse, ¿cuál es en general?
Entonces, cuando uno va a aprender o a enseñar, pues como mayor el repertorio es recomendable aprender directamente con la lógica de los paquetes de este universo o aprender primero.
Mina, Daniel is a student. He's asking a very interesting question about the potential difference about managing errors in the base R and tidyverse. So his question is more, should we learn the basics from R and managing errors first before moving to tidyverse, or should we go first to tidyverse and then going back to the basic R?
My pitch would be to start with the tidyverse. That's how I do it, and let me pitch my reasoning for it, and then I might talk a little bit about what might be reasons why you think otherwise. So as I said, I primarily teach students who are coming to learn stats or data science and who have no computing background whatsoever. So what we want to do with these students is to get them to a point of doing data analysis as quickly as possible, and not just simple univariate data analysis, but multivariate data analysis. And also to get them to a point of taking a real data set, not a curated one for a classroom, but a real data set with all of its messiness, get it into the rectangular format that we like for doing statistical data analysis, and then to be able to implement that. The suite of tools the tidyverse offers, and the in between these and the kind of the cohesiveness of the packages within the tidyverse, including how errors are handled, including how errors are presented and how you would read through them, I think is a wonderful way for getting people started with things. It's not to say tidyverse is a set of packages for just beginners. No, it completely grows with you. It just happens to have this shared philosophy between the packages that maybe students a little bit from all the idiosyncratic things that are in BaseR that happen to be there only because as they were being written, the objective of the objective behind them may not have been cohesiveness, but something else may have been trying to be optimized. Now, the question about if somebody starts learning this way, are they able to learn other things later? And my answer is absolutely yes. And the reason, and my personal kind of empirical evidence for that is that I've taught students like this over the years, and I have students who have started with tidyverse in my class and are now data scientists elsewhere. And not only are they using R and all the packages in R, that's base R, tidyverse, data table, they're most importantly able to make the decisions for themselves as to this is the question I'm working on, this is what I'm trying to optimize, and that's why I'm going to use that tool. What we want ideally for our students is to be able to get to that point, to be able to make those decisions for themselves. And if you start teaching them in a way that is going to cause so many trip hazards along the way so early on, I think you might lose a good chunk of those students before they can get to that point.
Thank you, Mina.
¿Hay alguna otra pregunta? ¿Vas a preguntar? Yo sí tengo una pregunta. Sorry, being an instructor myself, I would like to ask you something kind of confusing sometimes for me. How do you approach an audience that has no idea about programming, no idea about R, and they are willing and eager to know and learn about data science? Just give me a second, I will try to.
Oh, sure.
¿Cómo hace, cuál sería su recomendación o qué haría para enseñarle a la audiencia que no tiene ni idea de programación, ni idea de R, ni idea de estadística, pero quiere aún así ser un científico de datos, quiere trabajar en analítica de datos? Okay, go ahead. Sorry.
No worries. So that's a great question for me, because that's really the audience that I work with. And my kind of short answer will be that you want to get them doing something in R as quickly as possible in the first class. So the personal goal I set for myself is for students to get to their first data visualization within the first 10 to 15 minutes of the first day of class. Now, this might sound pretty ambitious, but here is how you might be able to do this. If instead of having students download software and set it up themselves, you're using a server access to RStudio, whether through RStudio Cloud or something you've set up for them themselves. And they can access it with some authentication they already have available to them, either through a university or like a Google account or something like that. And they go in and they are encountered with an R Markdown file that you have made for them that just knits perfectly as is and has some interesting, not super complicated, but not very, very basic either, data visualization in it. And so within the first 10 minutes, we can get them to a point where they knit and see the data visualization and then actually start interpreting it. Now, obviously, the code is completely foreign to them. So what I like to do in the next 15 minutes or so is to have them make one change to the code. So a data set that I've been loving for this is a data set from the United Nations about voting patterns in the United Nations. And I build a visualization for them that has something like Turkey and US and UK in it, because those are countries I've lived in. And I ask them to change one of those countries to another country that they care about. So some of the international students would change it to a country that they're from, or maybe if there's a domestic student, they might change it to a country they've been to. And all they do is they change one line or one word in one character string in a line of code, knit the document again, and see the result. So we have gotten them get used to like what the workflow looks like and what code looks like. And what I do is over the next 4 or 5 weeks, deconstruct that plot and get back to that after about 4 or 5 weeks of teaching and saying, hey, remember that one visualization? Now let's take a look back at that code again. And they're at a point where they can actually understand what that code is doing. So in a nutshell, I would say the tip is to start with data visualization and a computing infrastructure that allows you to get students working right away. I have talked a little bit about this in another talk I mentioned called Let Them Eat Cake. So if you look in the talk I've given in the past, there's videos where I give a few more tips about working with this sort of audience and what I mean by the cake. But basically, visualization first is my short answer.
Thank you.
¿Hay alguna otra pregunta, algún comentario para Mina? Mina, from the Rday Medellín 2019, we would like to thank you for your wonderful talk and your wonderful answers, and looking forward to hearing from you soon and being in contact with you in the future. Thank you very much.
Wonderful. Thank you so much. Bye.
Buenos días. Buenos días. Buenos días. Vamos ahora a pasar a las sesiones de tutoriales. Aquí tenemos un tutorial y en otros dos auditorios, encuentran el auditorio caso 3, encontrarán los otros.
Creo que no la grabamos.
Para que ustedes acompañen. Aquí queda